In this video, we'll talk about some of the terminology associated with characteristics of trigonometric functions. The idea here with trigonometric functions is that they do repeat. The examples that we looked at were the depth of water when the tide is coming in or out, so that's a very periodic type of behavior. The water level would drop to a certain point, and then it would start to rise again, and that process just repeats day after day after day. I guess we should talk about what does it mean for one cycle. So one cycle is one complete wave. So if I were to draw, we've got a graph here showing a trigonometric function. If I were to draw sort of a box around this one cycle, I might draw that box right somewhere in here, say. The reason why I know this is one cycle is I started the graph here. If you look at the y-axis, the graph starts at 5. I've gone up, come all the way down, and go back up to about 5 right in here. So you can see that that's one full cycle. So it's important that you get all parts. So the increasing, decreasing, and then back up again. You could also measure one full cycle. I won't do it on the graph, but you could also measure one full cycle as from here to here. So from the peak all the way down to the bottom and back up to the peak. We can measure it from here, so the trough, all the way over to the next trough. So all the way back up and back down to the bottom. So that would be a cycle. And when we talk about cycle, we often want to measure that cycle with what's called the period. So the period of a periodic function is basically the horizontal length that is required to complete one full cycle. So here, the cycle started here at, if this is time or whatever this happens to be, the x value here at 0 is 0, and then the y value is 5. We said that the cycle ends over here. So we went from x equals 0 to x equals 8. So that would be that would mean that the period here is equal to 8, whatever these units are. And I didn't include any units, but so the period of this particular function would equal 8. Again, whatever those units are. So it could be hours, it could be days, it could be minutes, depending on what it is that you're measuring. If this is an example of a Ferris wheel, say, you might be talking about minutes, an 8-minute sort of going around the Ferris wheel type of scenario. Again, I could measure that period from anywhere as long as I'm doing one complete cycle. So I could measure it from x equals 2 all the way to x equals 10. Well, if I do that, well, I want to know what is the distance, the horizontal distance from x equals 2 to x equals 10. And we can find that just by subtracting those two. So 10 minus 2 gives us 8. And you see that's the same answer that we got over here. Anywhere we measure the period on any particular graph, it should always be the same. If it's not, maybe we're not getting the entire period. The other piece of terminology, that we should talk about is what we call the amplitude. So the amplitude is, that shouldn't say half, but should say half the distance between the maximum and the minimum values. So if here is the maximum value, here is the minimum value, and we want to know what half of that distance is. And we can do that by just subtracting the two values. That will tell us the distance from top to bottom. And then dividing it by 2 or multiplying it by a half. So in this case, if we do half, 1/2 of the max was 10, minus the min here, the min was 0. 10 minus 0 is 0, let's try that again. 10 minus 0 is 10, half of 10 is 5. So the amplitude is 5. And what that's telling us is it's telling us that the distance from the middle, so this was the middle of the graph that we talked about, sorry, right in here, from the middle to the peak is 5, and we can verify that. Our middle here is 5, and we go up 5 to get to 10, and we go down 5 to get to 0. So that's the amplitude. So, and again, we can measure that amplitude either from the center to the max, or we can measure it from the center to the min. So here we would get a distance of 5. Again, from 0 up to 5 is 5. From 5 up to 10 is also 5. Now this one happens to be pretty easy because our minimum happens to be at 0. But if it weren't at 0, again, we would just subtract whatever that minimum happens to be. And then the last characteristic that we want to talk about here is what we call the sinusoidal axis. So the sinusoidal axis is the horizontal line that divides the graph exactly in half. So horizontally. So here's the horizontal line. This line divides the graph in half. Half of the graph is above the line, half of the graph is below the line. So this would be the sinusoidal axis, sometimes abbreviated as just axis. So this line right here is the sinusoidal axis. And this line is a horizontal line. It has an equation, and that equation of a line is always y equals some number, and that some number is whatever the value is here, whatever the y value is here. We know that the y value here is 5. So for us, the equation of that sinusoidal axis is just y equals 5. And we can tell that pretty easily by looking at this graph. Sometimes it may not be that hard. It may not be that easy. Sometimes you may want to think about how to do this another way. Well, it's just halfway between the max and the min. So we want to know the midpoint here between those two values. And the way that we can find that is just to find the average. So the average here would be 10. That's our highest point, plus our lowest point, which is 0, and we divide by 2. So 10 plus 0 is 10, divided by 2 is 5, so that's how we can get our equation. Again, this one works out pretty easily because of that 0, but that process will always work. All right, so that's some terminology. Let's just look at a couple of graphs here. So here's a graph very similar to the one we just did. Again, this one might represent a Ferris wheel. So you get on, this would be, let's say, time here, maybe measured in minutes. This might be your height above the ground, possibly measured in meters. So you get on the Ferris wheel at the bottom. This isn't a huge Ferris wheel, I guess. And then you start to go up. You hit the maximum height of 10 meters, maybe 4 minutes later, maybe a slow moving Ferris wheel. And then you start coming back down and you hit the bottom 8 minutes after that, after you've started. So one complete cycle would take 8 minutes. And we can do that cycle again. We can find the amplitude. So the amplitude here and the sinusoidal axis is the same as it was in the previous graph. Here's the axis right in the middle at y equals 5. But what I really want to show you here is that maybe it doesn't make sense to talk about this portion of the graph. You know, if we're talking about getting on the Ferris wheel was just set up this morning, maybe it doesn't make sense to talk about time that's negative. So one of the things that we'll do eventually is you'll have an opportunity to create equations that represent these situations. And this is an example of the one that was created to make this graph. But maybe you don't want to show this part because maybe it doesn't make sense to have negative time. So one of the ways that we can do that is just with these curly brackets here and indicating that we only want to show when x is greater than 0. So remember, this is the greater than symbol, just meaning that when x is bigger than 0. And what that does is it restricts the domain of this function. So we're only looking at what happens when x is greater than 0. So again, you might see a graph and you might think, well, it's not sinusoidal because it doesn't continue forever. It's possible for us to restrict the domain. And we can do this with any function. This was all done in Desmos, and that's how you can do that. I want to show you one more. What if we want to restrict at this end as well? So maybe we want to just show what happens can we just show one cycle? So I'll just quickly show you that. So here it is, one cycle of the graph. You can see that it starts actually right here and it ends right here. And the way we do that is we tell the software to restrict the domain to x being between 0 and 8. So this says that 0 is less than x, or x is bigger than 0, and x is less than 8. So then it only shows those parts. So again, it is still a sinusoidal graph, even though we don't get that periodic nature because we've restricted the domain. In actual fact, the graph does continue, but we're saying I only want to see this part of it. So again, if you're talking about a Ferris wheel ride, maybe you only get one loop around the Ferris wheel and that's it. So we only want to show one full cycle. All right, so that was an introduction to some terminology of trigonometric functions.